where I need to make the water. Suppose this is my field. This is my field. So this field I want to identify where I need to more water stress. This type of things I want to identify. Okay, so for that, in this time we are just use here the NDWI, basically normalized difference water index. Then we also use here the LST land surface temperature. We also use here the soil moisture, okay, SMAP. And finally we try to apply the water stress. Okay, we just make the water stress. So then we can easily find out. So this type of red color in this map, we find out it's the very high stress of water in the field. So you can see this type of field, this type of red color, it's identify about the high stress of water. Okay, this type of place, this type of place, but this type of green color is not a stress of water. So for this land I don't need to provide the irrigation, but for this type of place, this type of land, this type of red color, it show about the more stress of water. Okay, and if you check, suppose stress class, we also try to make the stress class. So this is the water stress index. So after creating the index, we also make the stress class. So we find out this type of stress class. So this type of red color indicating about the high stress of water, this type of red color. So this type of plant or this type of crop plant, we need the water. Okay, so it's a very high stress. Then suppose it's low and it's very low, this type of green color, it's not need the water. But this type of red color, you must need the water because it's a very high stress, water stress, we find out. So now how I can monitor this type of thing, I'll try to explain in here, all of data set. So first of all, we simply define our study area, this field, and then I simply take this type of season. Suppose January, February, March to May. Okay, just take the May. So this is the peak rain window, we just simply put in here. And then same process just apply. We simply make the cloud max function to remove the cloud from our satellite imagery. Then I take the sentinel to harmonized imagery. Okay, in this case the same process just apply and make the NDWI, because now I want to make the NDWI. And if you check, I just add the NDWI map. This is the NDWI map. If you want, you can also just show the result, just stressing that it will look more better for mapping. NDWI basically is normalized water index, so we can easily identify for the water where is the high, where is the low. We can get this type of idea from the NDWI. So in this time we are just identify water stress based on NDWI, then land surface temperature, and also soil moisture. So using these three factor, we identify where we need the more stress of water, where is the less stress of water. So this type of things I try to monitor using in here. So if you check, this is the NDWI, so we can easily identify. So this type of place, okay, so you can see basically minus 0.8 and then minus 0.1. okay, so it's not the water, but NDWI is very high for this type of place. Okay, this type of color indicating with high, it's not the water, but we find out that very high NDWI for this type of place. It's also negative because it's a vegetation. Okay, it's a vegetation. But if you compare this value, then we find out this type of place is also have more water than this type of others, this type of color others. Okay, so this is the NWI. We simply may calculate the NWI and also take the NWI, and then we take the LST. So in this time for the LST, you can use here the MODIS, there is no problem. You can use here the MODIS. If you want, you can also use here the Landsat imagery, Landsat. If you want, you can also use here this one, suppose Sentinel 3 we can also use for monitoring the LST. So this type of MODIS, Landsat, you can also apply, there is no problem. But in this case I just take the MODIS. But when you apply for the small study area, then try to apply the Landsat, so it provides the more better result when you apply the Landsat satellite imagery, because it's 30 meter. Okay, so in this case I just apply the MODIS. So this is the MODIS satellite data, and this MODIS satellite data, if you check from here, just check the data. So this is the land surface temperature data. From this data you can get this type of result. LSTD 1 kilometer, unit is the Kelvin, and this is the scale we need to use for reproject the scale value. So now I simply apply, then also filter bounds with my study area, then filter date, I put the start date and end date. I select my specific band, and further I simply multiply 0.02 to make the reprojected the scale value, and subtract this value to get the result in degree Celsius. Okay, and rename it as a LST. So now we simply return the LST as a band. In here I can put the LST, average LST for my field. If you want, you can also display, I just display the average LST of my map, so you can find out this type of result. You can check because this resolution is the 1000 meter. Okay, that's why you find out this type of grid or cell. Okay, this type of grid or cell find out because it's the 1000 meter pixel size. Okay, we can find out this type of things. But when you work with the real project, suppose for your real study area, then try to apply for land set, because land set is 30 meter, then we find out the more better map. So now it show you this type of grid or cell because it's the modis is the 1000 meter for pixel size. So now I just simply use this for the LST, and finally we also use at the this data. It's called the soil moisture data. Okay, from the NASA SMAP we take the data, but this data set is also not better for using for the small study area. You can check this resolution is I think 1000 meter, you can see 9000 meters. Okay, this is not much good. So that's why further class I also discuss about that how we can easily use the Landsat imagery and make the soil moisture map. Okay, this thing is very important for the small study area. When you suppose for the small crop area you want to monitor, then try to use the Landsat imagery because Landsat is 30 meter. But now in this case I just use it because it's ready-made data. We find out in here soil moisture, we find out in here, and 9 kilometer grid or cell for the soil moisture. So this data I simply use in here. But when you work with a small study area, then try to apply for Landsat image, Landsat, to grab the soil moisture.
Is it possible to derive soil moisture from the Landsat?
Yes, it also possible, but for that we need to apply another algorithm. So inshallah I will show you that how we can easily use it and identify for the soil moisture, as well as you can also apply the Sentinel-1 also, Sentinel-1 also. But for that we need the ground truth data of soil moisture. Okay, Sentinel-1 data for need ground data, okay, of soil moisture. Okay, then we try to use the soil moisture using the Sentinel-1 data. But for the Landsat we can easily apply algorithm and detect the soil moisture also. But this is the ready-made data globally we find out, but this resolution is not much good. So now we simply use it and compute the mean soil moisture. If you just check the map, so this is the map about the soil moisture. Just I try to show you that result. Just apply. So you can see it show this type of cell or grid. Okay, only for 3 cell is fully fill up my study area because this is the 9000 meter pixel or grid cell. Okay, but when you work with the real project, then you try to apply for Landsat or Sentinel, then you can find out the more better result. Okay, you can see it show you only for the 3 cell. Okay, so now we find out this type of cell, it's indicating about the very high stress of water. Okay, and then it's very low soil moisture low, and it's very high. Okay, and it show this type of result because it's the 9000 meter pixel size or grid size. Okay, so I take it this type of data from here, and finally we just make the water stress. Okay, so for the water stress we just create the normalization. Okay, normalization basically we need to reduce. Okay, we need to reduce all of those normalization, and I just for that all of data set just keep the same scale when I compute the value using the normalization. So in this time I just take the 250 meter all of data, suppose it including all of data. Okay, so it can be soil moisture or also for your NDWI or LST. So I take the all of those and then I simply stress the percentile. Okay, 95% will take to compute, and then just simply apply, connect the band, all of band together. Okay, and then okay, it's not need. So now we calculate the 95% percentile, and we just simply return the, okay, divided with this value, subtract with this value, and then maximum with this, and we compute. You can see, okay, so in this time you can see high NDWI equal to low stress. Okay, suppose if the NDWI value is high, so it means that low stress of water. Okay, then high LST value, suppose I find out the high LST value for any study area, so it means that high stress of water. Okay, and I find out suppose high soil moisture value. So high soil moisture value, it's indicating about the how, it's indicating about that low stress of water when I find out the high soil moisture value. So just we simply apply this type of things, just normalize. I just normalized and call this NWI, then LST and soil moisture, and connect with my study area. So this is my field, it stored my shapefile, this boundary. So then we simply compute. You can see, just apply the formula. So just I call the LST, basically LST add, and then subtract with NWI, then add with soil moisture. Okay, basically we simply add. You can see, just I add the LST, and also add the your you can see, add the soil moisture, simply subtract. These two things simply subtract in here, because it is the low impact of that your soil water stress, crop water stress. So for that LST, then add, subtract LST, subtract with NWI, then add with and subtract with soil moisture, and divide it by 3. And this thing we simply apply the rename as the water stress. So now we find out this type of water stress map. If you check, we find out this type of water stress map. Okay, so now for this type of place, we find out suppose NWI is very high. Okay, high NWI value, and LST is low again, and soil moisture is also high for this type of green color. So that's why we find out that it's very low stress of water. And finally, we just simply make the class. Okay, we just simply make the severity class. Suppose we just simply low, moderate, high, and severe stress. So for that, we simply just, you can see, I take the stress. I just call this variable stress and make the class. Yes, please. Please.
I have not understood the code above there.
Okay, just I try to explain again. So in this case, we try to identify stress using the 3 factor. First factor is NDWI, second factor is the LST, and third factor is the soil moisture. Okay, suppose
Yes.
for a study area, suppose this study area, NWI value is very high. If the high NWI value, it's indicating about the low stress. Okay, and low NDWI value, it is indicating about the high stress. Okay, invert. Suppose this type of place, I find out that high NDWI value. So this high NDWI value indicating about the low stress. But this type of place, I find out the low NDWI value. So it's indicating about that high stress. Okay, or vice versa. Then high LST. So high LST, suppose this type of place, we find out that low LST. Low LST basically indicating about the low stress. Okay, but high LST indicating about the high stress. This type of place, we find out the high stress. And finally, soil moisture. Soil moisture, if the soil moisture value is the high, it means that low stress. Okay, and if the soil moisture value is the low, it means that high stress. Okay, suppose for this type of place, soil moisture is very low. Okay, this type of region, red color, soil moisture is very low. So that's the reason we find out that high stress. And this type of place, soil moisture is very high. So that's why you find out that low stress. Okay, and finally, when you compute the stress in this time, we simply call the LST. Okay, LST. So this is the LST. This LST we simply subtract with NDWI. Okay, then subtract with,
Norm
yeah,
norm 01. What is norm 01?
which
Norm 01.
which one?
Norm 01. You see, norm
Oh, normalized.
variable
It's called the normalized. So you can see,
normalized.
yeah. So for that, we create a function. You can check. So in this case, we create a function normalized, and we define the image and region. So all of data. So in this time, we have total 3 data: NWI, LST, and soil moisture map. So all of data we simply normalize 0 to 1, 0 to 1 value. Okay, all of data we just simply normalized
Yes.
0 to 1, and also keep the same scale when you compute the normalized. So this is my function
Yes.
normalized. So I simply call the normalized function variable name in here and define the ndwi. I already make the ndwi if you check. So just I simply call it. Okay, just I simply call it ndwi. This thing I simply call and paste here. Basically I simply use it. This is my function. I simply call it, and this is my study area. So this is my function. I simply call the LST. I already make the LST average. You can see I already make the LST average. So this thing I simply compute and then connect with my function. Okay, this this variable basically stored the function. This function I included the normalize all of data and compute the normalize 0 to 1, and then we simply connecting with our value. Suppose this is the value for NWI, and this is my study area. This is the value of LST, and this is my study area. This is the value of soil moisture, and this is my study area. So now I simply use all of those, and it is stored in this variable, in this variable, in this variable. I store it normalized value. Okay, this variable is stored the normalized value. So this is my function. So I create a function, and this function I simply use different factor. Okay, so now further I simply apply this formula. Okay, this formula basically LST subtract with NWI and subtract with soil moisture and divide it with 3, because we have 3 factors, and then we simply rename is the water stress index, and then we just simply get this type of water index map. So this is my water stress index map. So from this index now we can easily get where is the high stress of water, this type of place, this type of red color, and this type of place is the low stress. And further we also make the class. Suppose I just make the 3 class, low, moderate, and severe. So how I can make the 3 class? So for the 3 class we simply call the stress. I put the less than. If the stress value less than 0.33, then we make the low. Okay, and then add the stress greater than equal 0.33 and stress less than 0.66. Okay, between this range we find out that 2 basically moderate. This is my another class. And finally stress if the greater than equal 0.66, we make the another class 3 is the severe. So now we finally we simply add this map. If you check, we find out the stress class. So we find out this type of it's the very high stress. Okay, this type of stress less than 0.33. Okay, very high stress. This type of red color, sorry, this type of 3 color, this type of red color. Okay, it's the class 3. It's the class 3. This type of place is the class 3, because this type of place stress value is the 0.66 greater than. If you check the value, suppose just I show you the stress value, just click on the red color. So this value will be greater than equal 0.66. If you check, this is water stress value will be greater than equal 0.66. We find out the 0.7. Okay, 0.7, which is the greater than equal 0.66. So this type of place we find out the high stress of water. Okay, then this type of yellow color, it's indicating about that this range 0.33 to 0.66, this range it is the moderate. So if you check it, just click on here. So now we find out the value between this range 0.33 to 0.66. Between this range we find out the yellow color, and it's indicating about the moderate stress of water. Okay, we find the 0.5. Okay, 0.5. So this value belongs with 0.33 to 0.66. So it's a moderate class. But if you check this type of green color, it's indicating about the low stress. Okay, low stress less than 0.33. So we find out the less than 0.33 for this type of green color, and it's indicating about the low stress of water. We found the 0.1. Okay, so that's why we find out this type of map for the water stress map for our study area. So it's low. This type of green color is the low stress, the yellow is the moderate, and red is the very high stress of water. Okay, did you get the idea about that?
Yes, yes.
Okay.
Yes.
So further we try to check the area. Suppose how much area is available for that water, high stress, low stress, and also moderate stress. So this is the layer. We simply add all of classes and also add the legend. Okay, this type of legend. So it's not mandatory. Okay, so we try to calculate the area. So it's very easy. We already know about that how we can actually make the area. Okay, suppose for that okay, so this is the legend code. So now it will be start from here. So we simply calculate the area. Suppose low stress how much area, moderate how much area, and severe how much area, or extreme how much area we try to identify. So for that, here I already calculated the area. If you check, we find out that area total 3 class. So this is the low. We find out that area is a 24 square kilometer area. Then we find out that moderate, this moderate is for 151, and find out that how much area for severe or extreme. We find out the 21 square kilometer area, red color. This thing we can also define using the chart. Okay, just make a chart and define the area also. Okay, just click on here, then you can get this type of chart, water class. So you can see low stress 24 square kilometer area. Then moderate is the 151, and severe we find out the 21 square kilometer area for our study area. We find out this type of water stress class. Okay, so this is the calculation part. I also seen you the code. You also try to use the same code for the calculating the area, but this is the main step to identify for water stress. And in this case, I just take the big study area, but when you work with the small study area, then you need to change some data. So we need to apply for the land set, because this soil moisture data is not good. So this soil moisture data is the 9,000 meter. Okay, so that's why it not show you the more better result for the small crop area.